Pradeen has already introduced. My name is Tufail Ahmed, and I will be delivering a lecture on statistical data analysis using SPSS. There are many software that you can use when you have quantitative or statistical data, and we will be using SPSS today. It is a statistical package for social sciences, and it is a very common used software when you have statistical data. I would like to introduce myself again to the participant. Currently, I'm doing a PhD from Institute for Mobility. We call it IMOB as well, from Hasselt University. I'm in my final year doing the last part of my PhD. Hopefully, I will be defending before the end of this year. And I have also done master degree in urban and regional planning from University of Technology, Malaysia. Before joining PhD, I have also worked as a lecturer in Department of Urban and Regional Planning in University of Peshawar. So currently I'm doing research on sustainable mobility. More specifically, it's about bicycle use in urban areas. So I'm an advocate of sustainable mobility. If you are traveling in urban areas, you should use bicycle for short and medium-sized trip. So this is my goal and my aim to promote because it has environmental benefits. Uh, in congestion, you can move faster, and also you have individual benefits. For example, your health is increased if you're using the active mobility. So what we will be covering today, this is a brief outline of the topics that we will be covering in this lecture. Firstly, we will talk about like what is data, what can we call a data, and then what can be the differences between quantitative and qualitative data. You already had, if I'm not wrong, you already had a session on qualitative data, so I will briefly introduce you to quantitative data as well. And then what can be the types of data and from which sources can we collect data? And more importantly, what is the importance of data? Let's say we have data, how can we use it? What is important for us as a researcher? What is important for government? What is important for you as a student? And then we will dive into practical aspects, showing you the interface of SPSS. And then we will see how can we manage data, do some hypothesis testing, and at the end, we will end our lecture with correlation. I will also show you, because we have a 3-hour slot, so we will be trying to catch up as many things as we can, and I will show you how can we run an analysis or a modeling, you can say, for example, logistic regression model or multiple linear regression model. But it's not in my slide. I will try to do that at the end of my session. So, Dr. Adil, I would like to ask a question. Can they answer? Can I hear them if I ask a question?
I think I am audible
Okay,
now.
okay, yeah, I can hear you. So what in your, it's a question for the people in the session, what do you think, what is the data? Can anybody like tell me what do you think what the data is? Anyone from the class?
Very simple question. What is data?
Information numbers.
Collection of
Information, one
Yeah, that's true. It can be information, it can be number.
numbers, yes.
Yes. So as someone told that data is basically information. And what is this used for? It's basically used for reasoning, discussion, and calculation. So we have any information, it can be a number, it can be even a word, it can be a name, it can be anything that we call the data. It can be used for discussion, reasoning, and calculation. So here are some of the example of the data which we can have. We can have an absolute number, let's say 10, 20, 50, 15, anything that is an absolute number. For example, how many runs you score or how many points you score in a football match. It can be an absolute number. It can be a continuous number, let's say temperature in your city. It can be height of a person. It can be a continuous number. By continuous number, we mean the number that have points that are continuous. An absolute number is, let's say, 10. That's an absolute number. We can have ranks. For example, the degree of your education is a rank. The higher you go, the higher level of education you have. It can be a group. You can, for example, gender is a group. You can either be male or female. Uh, Type of car is a group. You can have a BMW car, you can have Mercedes-Benz, you can have Toyota. So it belongs to a specific group. And it can be any other thing, like it can be images, it can be names, it can be sounds, it can be videos, it can be anything from where we can extract information. So this is what data is about. So now what is the difference between quantitative and qualitative data? Usually quantitative data is numerical, and I hope everyone know what numerical data is. And quantitative data, it is mostly descriptive and non-numerical. As I told in my previous slide, it can be names, that is qualitative data. It can be an interview of a person, that is qualitative data. It can be a piece of newspaper, it is a qualitative data. So quantitative data, it represents quantities and can be measured and is counted. Let's say if I want to start counting number of students in the classroom that are sitting, so I will end up with a number. For example, there are 5 students in the class. If I want to go outside in the parking lot and I want to measure how many vehicles are parked in the parking lot, so I will end up with a number. So quantitative, we can measure, we can count. But in qualitative data, it has qualities, it has characteristics and attributes. Let's say if I want to talk about Dr. Adil, I will have some qualities of him. If I want to talk about any person in this classroom, there will be qualities attributed to it. Let's say he is a sober man, he's a well-dressed man. So these are the qualitative data have its qualities which we write to describe it. Here are example: height, weight, age, number of item in a grocery store, scores in your exam. So these are the example. And if you talk about qualitative data, if I want to describe a color, how would I describe a green color? I think I will not have any numerical thing to describe it. So we will describe how green color is. Similarly, texture. Similarly, if you want to smell the food, how would you will describe it? You cannot quantify it. So if the food is smelly, if you want to tell your colleague how does the food smell or taste, you will describe it. So this is the difference. And we use statistical methods, let's say frequencies, charts, diagrams, graphs to show our quantitative data using statistical methods. And in qualitative data, we use thematic analysis, content analysis, or coding. These are the tips and tricks or data uh, methods that can be used for qualitative data. And as I told you, we for quantitative data, we have clear charts, we have graphs, we have a statistical summary, and I will show you them in SPSS how can we create tables and charts for our data that are in numbers. You have a table, you know everything about your data. And here we have some narratives, we have quotas, themes, and conceptual model based on our qualitative data. Now, when we come to statistical data, we categorize them into four major categories. Firstly, is this because this is used in SPSS later on for the data analysis. So as I told you, we can have an absolute number, and in statistical term, we call it discrete data. I have given you example before. I will give you example again. Student in the classroom, it's a discrete or an absolute number. This is a type of discrete data. Again, cars parked in a parking lot, goals scored in a football match, or car owned by a person. 1, 2, 3. Continuous data. Here are the example of continuous data. It can be temperature of the city, it can be height of person, or when you're traveling on a car, how much distance do you travel, or what was the speed of your car. The next one we call is nominal data.
So, Phil, I just
Uh,
wanted to clarify one thing here.
yeah,
Like between the discrete data and continuous data. For
yeah,
example,
yeah,
number of goals scored in a football match. Either it's 1, 2, 0, 3, 4. It could not be 3.5 or 3.2, right? The discrete data means you cannot go into decimals, right? For
yeah,
example, the number of students sitting in the classroom, we cannot say 7.5. either it's 7 or 8. But in terms of temperature, it could be 43.2 degrees or 41.2. So it could go to decibels. This is the difference between this discrete data and continuous data. Sorry, the file for
No,
interruption.
it's okay. That's a pretty clear explanation of what discrete and continuous data is. Thank you so much, Adil, if I have missed it. And the next type is a nominal data. Nominal data usually represent a groups. Again, gender, you have either male or female in your classroom. There, each person has a blood type. You can have only one blood type. You can belong to one group, either it's A positive, B positive, or O positive. Same thing goes to marital status. You can have certain groups. For example, you can be single, you can be married, or you can have other groups like, for example, divorced or never married. So you belong to a specific group. Same goes to hair color or type of vehicle. And ordinal data that's different from nominal data. And here we talk about the rating. Uh, it is from least to most. The higher you go, the higher level of data it has. For example, if I talk about satisfaction rating, if I ask you a question, how satisfied are you with your university? You will have ranking from, let's say, 1 to 5. If you say 1, that means that you are not satisfied with your university. If you say 5, you are satisfied with your university. If I ask you a question of what is your education, you will have a level. You will either have a degree of bachelor or master. The higher you go, the higher level of degree you have. You can have a PhD. It's a more higher rank. And if I ask you a question, how spicy the food was, you will rank it from 1 to 5. Again, it can be anything. Like the ranking can be from 1 to 3, it can be from 1 to 5, it can be from 1 to 7. Lower describe the minimum, and let's say 7 and describe the maximum. So we use the rank data, or you can say the levels, to define the data. And then what can be the sources of data? It's a question again for the class. What do you think can be the sources of the data? Anyone, please?
From where we can get the data?
Surveys. Yeah, I heard surveys. It's the right answer. Anything else? Any other source of data?
Interviews.
Interviews. Yeah, that's also correct. It is a source of data.
Articles.
Yes. Documents for one of our colleagues.
Yeah, that's right. So we have multiple sources of data here. A few examples of the data is we are an urban planner or transport planner. We usually go do survey and questionnaire. We have a specified format. We make questions. We go to participant and ask them a question about our research or project. The next thing is usually it's mostly what scientists do. They do experiments. They have some, I mean, let's say chemical. If they want to make water, they mix a specific quantity of hydrogen with oxygen, and they come up with water. So they collect their data using experiments. You can do observation. If I want to count how many cars are going on a specific section of the road in 1 hour, I will take my notebook and go out and start counting the traffic. Similarly goes to if you want to uh, do improve. This usually used for let's say in traffic study, we do that for improvement or any kind of project. If you want to see how is there enough space for bicycle to be parked, you go out and see and start drawing things, and based on your observation you come up with the data. We can go to administrative records, and we can, I mean, take data out from the secondary source. It can be from a library, it can be from internet, it can be from government records. And usually nowadays, the sensors and instruments are becoming popular. For example, traffic speed cameras. It is one kind of an instrument that can be used for measuring the speed. Also, number plate recognition cameras are used for that. And one sensor I used during my study was we want to measure bicycle roughness index of a city. So we had some smart bicycle light. We installed them on bicycle. We start traveling around the city, and the sensor was smart. It was able to collect vibration data. It was able to collect speed data and so many other stuff. So these sensors and instruments are becoming popular these days in urban planning and transportation studies. But these are not the only sources of the data. As someone mentioned, that it can be an interview, it can be a piece of paper, it can be a video or an audio, and there are many others that are majorly used in qualitative data. So, importance of the data for me as a decision, as a researcher or as a government, uh, based on the data, I can make informed decision. If I base my decision on data, probably I'm going to make a wise decision. If I don't make decision based on the data, probably I will take a wrong decision. So anytime if you want to make a decision as a government or as a university, as a person, you always have to make it based on the data. An example of it can be if you want to construct a new road, city planner will usually collect traffic data, and then they will determine that is there a need for construction of new road or not. We can use it for problem solving. It will help us identify an issue, and the issue, if it's identified, we can develop a solution for it. What can be the example? Analyze traffic accident data, and then by analyzing traffic accident data, you can do a hotspot analysis, for example, in GIS, and you can identify high risk areas. And if you know high risk areas, you can improve the situation by implementing some safety measures. And then probably you will be ending up less road accident in future years. You can use it for predictive analysis, like as an urban planner, what we usually do is we forecast data, we plan for the next 10 to 20 years, and we have to see historical trends. What are the trends? Let's say how much the population is growing, where is the expansion of the city going, and where is the need for housing. So you can use historical data of the population growth in urban sprawl to predict the future housing need and infrastructure need. Where do you need housing? Where do you need to plan the parks? Where do you need to plan the new roads? Because it will be based on uh, the historical trends. We can do predictive analysis. And similarly, you can do scientific research using the data. There will be theories developed in past. Some scientists come up with a theory. You can either validate them or you can add a new knowledge to the existing scientific literature. You can either, if you have data, you can even make your own theory. You can even contradict a theory that is in the past. So now the interesting part that we all are waiting for is SPSS, and here we will use the data or the discussion we have done so far. This is basically the interface of SPSS. When you open a new file, usually it will be empty, but now you see some figures, some digits. This is because I have opened a data set. That's why you see some numbers are in some gender like male and female. But usually when you open an SPSS, it will be an empty sheet. So we have columns and we have rows in our data sheet. And this is usually in the data view. And what column represent? It is basically a variable. Let's say gender. Gender is my variable. It can be male, it can be female. Similarly, age group. So when I go to collect my data, so I will have list of variables. I have list of question, and this list of question will come into SPSS. And then this column represent your variable, and this rows represent the case. As I told you that your age group, this is a case specific to a person. So rows represent a case value. And this one is your variable view. And what we do here, we insert our variables here. Let's say the age group, and then we ask question and put the data in the data view here on the left side. So we can put information about the variable, what was the name of the variable, how can we label them, and what was the scale. As we talked before, the type of data, so we will mention it here. So we always have to try that we write the right name of the variable, because it is very important for later of the analysis. And then you have another view that is called overview. When you load a data, it gives you trends of the data, what kind of data you have. For example, in this data, I have 50% of scale variables, I have 25% of ordinal, and 25% of the nominal variable. So it gives you trends in the data. And lastly, you also have another view that is called syntax. This is kind of programming itself in SPSS that is now developed also. And syntax, when we run any operation in SPSS, we can paste them here. When you paste them here, you can share, it will develop a code. You can share this code with your colleague, with your just use this run function and you will have the same result again. So I'm going to SPSS now, opening SPSS. So I will show you practically these things which I have shown here. You can also open up your SPSS. So normally this is the data view which I was, I think you cannot see it, right? I will
Yes.
share the screen. Okay. Mm.
Have you opened the SPSS software?
Yeah, I have opened the SPSS. I will share it with you guys.
Okay, okay. In the meanwhile, I will explain just one thing to them. In SPSS, we have rows and we have columns. On the columns, on the top of the columns, we write the names of the variables. For example, my first respondent was Fatima. I am asking her about, for example, about her age, about her education, about her income. Just these are different variables. In the rows, I am adding data related to only one respondent, which is Fatima. The second respondent is Raida. Same questions. In the rows, the respondent is now number 2. Respondent number 3, again, the rows has the data, columns has the variables, right?
Yeah, right. So you can see my screen now with SPSS open.
Yes, it was open, but now I'm just seeing your video.
Okay, I will share it again. I think it stopped when I opened the data set. Share
And even
screen.
Mr. Tufail, it would be wise you just open the software in front of them and even how to
Yeah.
import the file, everything you explain.
Okay, yeah, I will
Because
do
it
it
is for the
again.
first time for them, they are like using this
Okay,
software.
okay. I will try to share my whole screen.
Yes.
So in case if I move around, so you can see my whole screen, right?
Yes. Now we can see the software.
Okay, you can see the software. Usually, when you go to files and you come down to welcome dialog, you
Yes.
click it, you have some sample data from the SPSS software itself. So here I can open anything. Let's say I want to open a demo data set. You can type D and you will have demo data set because we will be using this data a lot during the course of this lecture. So when you open it, okay, open in a new window, let's say. So this is the new data open. So I was talking about data view. You click it, you have the data view. You click the variable view, you have the variable. I have already a lot of variable and data in this data set. I can add up anything. Okay, like education level. I can write it here. And then what is the and then I specify the width of it, like how long it can go in my data view. So if I have more width, I can add a lot of text to it. And then
Just 1 second, Tufail, just 1 second. I would request first we explain them what is data view, what is variable view,
yeah,
and then step by step, I think we start with the data
yeah.
view. For
So
example,
I showed them the data view. This is the data which we have once we have the data collected from the respondent. We have questionnaire, we go to person, and then we ask them, let's say their age category, their marital status, and this is the data view. Okay.
and
And the top rows shows the name of the variables. And this one, as I mentioned. And this one, it is the data which I collected from a person. you see it's married and unmarried. We will do it practically also for our data set. And this is your variable view. Okay, you have all these variable, you enter them. What is the type of variable? For example, it can be scale, nominal, and ordinal. How do you want to label them? You see here it is married and unmarried. I usually specify it here. What can be the value? I see two values here, married and unmarried. And when I want to enter data, I have to enter it in data view. So and
Just
then
I
we have,
like to add, Tufail, one thing I want to add here.
yeah,
If you
yeah,
go
you
to
can add
variable
one.
view, if you go to variable view,
Yeah, I will go to variable view. Yeah,
variable view. Yes, here, just step by step. In the
okay.
software, we have two things, data view and variable view. In the data view, I showed you, we have variables on the top, and
Yes.
each row is representing information about one respondent. Now, this is already a data that I have feed it in the software. But before we feed data in the software, we need to set some rules so that the software knows about it. For example, if I am uh, putting data in the software about the education level, there are different education levels that I feed it in the software. PhD, masters, bachelors, uneducated, four categories. I need to define these categories to the software also. For that, we will go to variable view. And in variable view, for example, let's add educational level.
Yeah,
So
actually, I
we
was
have,
telling, yeah, I have a slide
yes,
next to it. How can we? I just wanted to show them the,
yes,
I mean, the views of the, I mean, data view, variable view, and overview. And then the next slide of it was how can we add or
yes,
data
okay.
to a new data set. So I'm going to share my slides again, and they will see step by step and slides first, and then we will do them practically in a new sheet without loading any data, right? So I'm showing my slides again, if you can see them.
Yes.
Can you see my slides again, Adil?
Yes, it's
Okay,
fine.
okay, okay. I thought my voice is gone.
No, no.
Okay, so how can we add the data? So um, what we do usually, we as I told you, Dr. Adil also told you that we want to specify the data and we need to give information to our software. And here I have written like I want to add a new variable. It can be a name of the variable. It can be your education level, the data you want to collect about. It can be age group. It is the thing which you are looking for the data. And then I will give it a name, and then I will describe a type of it. If it is a numeric, so I will say numeric. And if it's numeric, I will describe how, let's say if I want to collect speed data, it can go to decimal. If it's a text data, it will not go to decimal. So we will specify it's a string data. And if we want to go to decimal, we can go to decimals. And then we have to label the data, and also we have to describe the variable type. Let's say I when you click this thing, the type, you see a lot of types. And if it's a text data, you describe it as a string. If it's a numeric data, you describe it as numeric. If it's a comma data, you describe it as a comma. And then you can also label it that this variable collect data about education in the label category here. And in values, when you click the values, you can add values to it. How can we add values to it? We will press plus, a new window will appear. And in this category, let's say I want to collect data about what mode of transport you use. So I will give software value 1 to bicycle. So let's say there are 5 types of modes of transport that we want to use. So if I will give values and give label to each of them. And when I say, when I want to later on add the data and press 1, software will know that this person is using bicycle. And if I press 2 and when I am entering the data, so software will know that this person is using car. And we can also do the spelling check. If there are any spelling errors, so software will identify. This is how we add data. And now we will do it practically. You can also open up your SPSS, a, So
Tufail,
when you
I
open,
give you, I request you three variables. We add in a new
okay,
data.
yeah,
The first
okay,
variable is age, for example,
okay,
age categories.
okay. So open up your SPSS and open a blank sheet,
Yes, this is a
and then
blank.
go to your variable view, and here you
My
can
first,
write
yes, my first
age.
variable is age, age. Yes.
Okay, so you write, you click on the name, and okay, you click here, double click, and then write age, and then you go and describe the type of it. And normally, age is
No,
a
no, that's
numeric.
fine.
Okay,
We just go to variable view for now.
yeah,
Variable view.
variable view, and then double click the first one, and you write age in it. And then you can go to describe the type of it. Normally, it should be numeric. If you want to add something, like if something related to other category, it's a currency, you can use dollar, or if it's a date, you can use. You click it and you can describe the type of it. So we are using numeric for this one. We will leave width as it is, because this is used for how long your variable can be when you enter it here. And then decimal, for age, we will not use any decimal, so you can leave it 0, because age can be an absolute number. And you can label this age categories, or any label that is convenient for you, because
That
here
is
we,
visible for you when you see your Excel sheet later on.
yeah, because here we use short words in the name, and label, you can write a whole line about it. And do we have values? Yes, we would like to describe values. If we don't describe values, you can just enter any number. So we can make categories. When you click on values, you will have another window opening up. Then you can add plus, and you can describe. Let's say I say 1 represent,
1 to 25 years, first category, for
yeah,
example, or
1
less
to
than
25 years, or
25 years of age.
yeah, this is your first category.
Yes.
And then you can add a new value 2. Let's say
26 to
25
50.
to, sorry,
Yes, it's fine. 26
okay,
to 50, for example, or
yeah,
30 is all.
26 to 30. Then you can add a new value, 31 to 45. Let's say we have 3 categories, and another one, let's say add fourth one as more than 45. Okay, you can do spelling check. If there were any spelling check, it will show you, the software will show you, but we don't have, so I have added them. Then education level, let's say,
The second variable, yes. 4
what,
categories, like one is PhD, second is master's, third is bachelor's, the
yeah.
last one is
And one thing I
uneducated,
would
for
tell
example.
them, that you cannot use space when you're writing your name of the variable. So
Yes.
let's say if I say education level, I use space, the software will give me an error. And you cannot use space when you are writing the name of the variable, that you can label them. So what I do, let's say for, I can use, as I told you, we use short names. I will only say education. And then I will go next. It can be text, because uh, okay. And here in label, I will use education level of the person. Here I can write the detail about it. And then when I use the values, let's say I'm adding values again. One is for bachelor degree. Second one is for master. Third is for PhD. So what else you
And
want?
four for uneducated, for example.
Yeah, one last thing. We have to define the type of data we have. Age is usually a categorical. So you see, we will use categorical. And also this one is also, we call it nominal data. I showed you in my slide as well. And education is also in ordinal data because it goes the rank. The higher go, the higher rank you will have. So we will tell the SPSS the type of data it is. And also we can use left, right, center. That is not important. It is basically where do you want to see the data when you have it here? Left side, right side, or in the center. And let's say I want to add the third.
Third
It can
variable, income level, the last one,
income.
income level.
I will say income,
Yes,
only income. It can be an absolute number.
yes,
Income of a person.
yes. Then
Label
you
is always for
define
me.
four
Yeah.
categories, for example.
I will. Yeah. No. Because we give values here, so we will not use any value here. I will say that it's a scale. It can be any value. Let's say 40,000, 45 point something. That's why I'm not using labels here. I will when I you got my point, Adil, Dr. Adil?
No, can you please re-explain?
Yeah. Here, like for age and education, I'm using categories. But for income level, I'm not using any category. You can write any number in it. Let's say your salary is 10,000, you write 10,000. Your value, your income is 40,000, you write 40,000. You don't use categories. Because we want to use a scale variable,
Just
just
one
as an
second,
example.
Tufail. Yes, I will clarify to them. For
Yeah.
example, education level has to be categorized always because it's either bachelor's, master's, uneducated. It is not a continuous number, right? Even for example, age categories, normally whenever we are collecting data from our respondents, we put them into different categories for our convenience. Either we collected data from young people, 25 years of up till 25 years of age, either from the people who are already like mature enough and they already like have certain understanding of the built environment, for example, 25 to 50 years of age, then 50 to 7. So we can categorize age and in the education level. But when it comes to the income level, for example, there are two options. Number one, yes, we can categorize uh, those people who have income less than 1,000 reals, those people who has income 1,000 to 2,000 reals, or those who have income 2,000 to 3,000. Otherwise, the other option is that we don't categorize them because it can also be a continuous number. For somebody, it's 700. For somebody, it's 800. For somebody, it's 1,100. For somebody, it's 2,500. So there are a lot of like I can say variability in the income level. So we can just Tufail, I will request here we also make categories of income level, four categories.
Yeah, we can also add categories.
Yes, less than 1,000 reals, 1,000 to 2,000. Then the third one above 2,000. Less than 1,000 reals. Oh yes, two is 1,000 to 2,000. Third one is 2,000 to 3,000.
Yeah. You can use categories, and if you don't want to use categories, you still can put number into it. If you want to put number, you will use scale because SPSS will then know that it's a number. If you want to use categories, then I will say that it's a categorized data. You
Nominal.
Is this clear now?
When do you use?
Okay. We use ordinal when we have certain order in our variables. Order means some certain ranks. Bachelor level rank degree, master's level degree, PhD level degree, ranking exists. Likert scale data is also a kind of rank, I told you. Highly disagree, agree, highly agree, ranking. Then we use ordinal. In normal categories, we use nominal. In case of continuous variables, for example, temperature. Temperature could be 42.3, 42.4. Then we use scale.
Okay.
Only three. Okay. Now, Mr. Tufail, now we go to data view. And for example, my first respondent is Mr. Habib, who is sitting right in front of you.
So
Uh,
what was your age? Let's say I say you are between
so
one to, yeah.
respondent number one is you are my first respondent. Okay. So your age is
27. So it will go to category.
category.
When you
Yes.
click it, when you click on the age, you will see the categories which you give and the variable view. So I will define your in this category. So what is your education level? I think it's a master. So I click here and I will see the categories. I will say you have a master degree. And then when I want to describe your income level, I will ask you, you
More than
click.
10,000 reals.
Yeah, I don't have a category for it.
Tufail, just 1 second. One student has a question. Yes, will
Yeah.
The options don't show. Don't show. We don't have that on the record.
When you go to the-
How about he explains everything and then we'll get the chance to read and.
So now, Dr. Adil, I have a small exercise for them. So I will finish this up, and during their hands-on, they can try adding up variables in the new view.
Okay, but you know,
So-
Tufail, what's the problem that they are getting? All of them, maybe you know how to resolve it. You have added variables in the variable view, right?
Yeah.
But
Yeah.
when they go to data view,
Uh-huh.
they don't see those categories in the data view when they click on the blank space. For example, you go to data view.
Yeah.
So when they click here, exactly here, now here you see a button where there are 4
Yeah.
categories appearing. In their
Okay.
case, like none of them is able to see the categories.
Oh. Uh, uh, did you try to resolve? Because normally you can restart the window again and try to do it again.
The options, which we.
Yes, do those 4 categories. Exactly. He understood it. So these 4 categories, for example, of income levels, 1 to 25, 26 to 30, these 4 are not showing.
Uh, um,
Maybe in the variable view, they made some
yeah.
mistake.
Did they, I mean, is everything clear in this? You see the role if it's input or what? In the variable view, see the role. What is there?
Input, all the categories are here. Decimals, 0 to 2, 888, numeric, everything is there. Now, guys, you go to data view.
And try to see the role is input that we are entering the data.
Yes. So well, like I don't know what's the problem, but in case of everyone, they have the same problem. They are not able to see the categories.
Okay, is it? I mean, the role is input or what in the variable view?
Input, yes, I checked. It's input.
If it's input, normally you should be able to see the categories. When you double click on it, or just try to write one manually.
Okay.
Can they edit? I mean, you can also write 1 or 2 or 3. If you don't see category, try to write 1 or 2. Then you might be able to see it.
So well, I tried. It's not working.
Okay.
Maybe we check on Google. What's the problem?
Okay. Another thing which we can do, try to open file and we will use existing data if it works for it as well. Try to open file and then go to welcome dialog at the bottom of the file. You click file and then go to welcome dialog.
Yes.
Open welcome dialog and open any data set that is, let's say, open accident data, the first one. Everyone try to open it because there you can also see. Are you able to open the accident data?
To fail a bit slow, please. Just 1 second.
Okay. Go to
Now
file
again, file,
and then at the bottom you will see welcome dialog.
welcome dialog.
Yes.
Yes, you click. Meanwhile,
Click
I'm
it.
thinking how to solve this problem.
You will open up. You will have some sample data. You click accident data, let's say the first one. Double click it. When you double click it, there is already a data in the SPSS. Are you able to open the data? Okay, and then now try to add values here. See if it works. Go to data view and try to add and see if you see the categories.
Still the same.
There's one.
I think it has to do with the craft version of.
No, I download.
Yes, yes. Tufail, you are also using the correct version or it is
No, I'm using a licensed version from the university. Maybe that can be an issue with the correct version. Maybe I'm not sure about it. Usually, I haven't faced this kind of problem.
That is from the official account, from the
Yes.
official website. So it's
Yes,
still
so
easy.
one of our student is also using official, but she's facing the same problem. Maybe in the meantime, we take 5 minutes break and
Yeah,
we
that
start
was I
with
was
the
also
class.
suggesting. Adil, try to open this. See it if it's working in the welcome dialog. If I open any save data in SPSS, it also doesn't work for it as well. We can try to figure
Doesn't
the
work.
issue.
It doesn't work, they are saying.
Ah, okay.
Yes.
It's strange.
Maybe just we
Okay.
take 5 minutes break and let me Google it, you also Google it. Maybe you will
Yeah, we'll
find
try.
some option.
We'll,
Just 5 minutes, okay?
okay. Yeah, yeah. Sure, sure.
Let me just try to resolve this problem. I will come back.
ما حاولت صراحة. لكن كبير مرة الحين. تقدري تفتحين على الشاشة. بس ترى الإضاءة مفتوحة. ممكن نسوي لها كذا. كيف تسوي لها كذا؟ ما كيف؟ واضح ولا مو واضح؟ عادي. عملت لي أنا إن شاء الله. الحياة. هذا لا ساعدني. بس حطي لي ايميل الويب سايت مالهم. لا لا ايميل. انا عملت عليه. اوكي يعني تروحين عند الاي ام تسوين اكونت. هناك تصيرين وين في بس عامله الويب سايت بعدين تحطين الحين لازم اضيف الويب سايت نفس الايه اي بي ام. اي بي ام هو بيعمل شيء. ايوه شوف الفاضي. أنا يطلع صوتين. وين تشرح؟
Okay. Where is that needed? Gone.
There was an issue with the software, so we took a break because everyone was searching for the problem.
Ah,
Trying to fix options.
لازم نسويها. أصلاً البرنامج هو اي بي ام في وايد ابس.
انا صار عندي بس ما اعرف ايش اسوي. ما اعرف ايش اسوي بس صار البوكس.
من السيتنجز ولا مش؟
انا ضغطت كل شيء.
ما بعرفش ما حتى لكن سويت بإيميل الجامعة ولا إيميل الجامعة؟ ما يفهمش حتى أنا مسؤولية عن سبب أصلا إيميل الجامعة هذا مش
So, is it resolved for someone or no?
Only for 2 year-old. But I didn't know what he exactly do. But then here some.
Okay. Well, like for one student, when he is trying to do it for the column number or row number 5 and 6, it is showing the category. Now it's showing for every category.
Yeah, only those 2. But here it's not working.
Because here you didn't select the right one. You are
Okay.
here it should not be. Accidents are also nominal.
Yeah.
Okay. And then population at risk is also nominal. Yes, here we have. These are continuous numbers. So now again one thing. Number of accidents and the population is a continuous number.
Yeah.
That is why this selecting scale. So the categories will appear only for those variables which are categorical, where the categories are provided. I think now, Mohammed, can you bring your? Yes. You know what was the reason I found it?
the major.
Yes. You open your data view, all of you,
The sample.
or data view. Tufail, can you please open your data view? I can show them. We resolved it. The data view in SPSS. Now you go to data view. You all click here. A1.
So the data.
Now you click here, and the categories will work.
Yeah.
Yes. Okay. So Tufail actually, like in the top,
Yes.
like in the top part of the interface where we see a plus button. Next to that, there is a button of A and 1. See this one. If we click on this one, then it works. It shows categories. Now your sound is gone. Please unmute.
Okay. So okay, they were seeing the number, not the categories. Yeah, that is what this function do. I thought they cannot even write, so I was looking for that. It's a strange issue. So normally, if you can see one, or if you put it like this, you will see one or two or three or four. And if you want to see the category, you switch it to value the values. So this button is used. Okay. So normally when you end data, it can be one, two, three, as we mentioned the categories. And if you click this one, then you see the categories of it. The one which we described or labeled them in our variable view. So it's clear now, so we can move forward, right? I think you already the first exercise. Sorry, is someone talking?
No.
Okay.
You can continue.
So this was kind of part of our first exercise that I wanted to practice you on. I think you have written and given the categories to it. So now the next thing which we will do, I will show in SPSS as well, that we how can we import a data. We already make a new data set if we want to make it in SPSS. If we have data in any other format, let's say we have it in Excel, or we have it in text data. So how can we add them? So normally I will show you the slides first, and then we can move to the SPSS part as well. Can you see my slides? Are they clear?
Yes, but they are not on the full view now. I'm seeing your slide show view.
Okay.
Meanwhile, I will clarify one thing. For example, we have conducted a survey, or we have received the data of the sensors from the adapted project. We received it in the form of an Excel file. We can directly import that Excel file into SPSS. How to do it?
Okay, so you normally go to the file view, which from where we opened our so then you can this one was we did it already, so I will skip this part when we open a new data set. So if you have data, so you click file, and then you go to open, and then you go to data. If you click data, you can see there are multiple types. A new dialog box will open. You will give the path from where you want to import the data in your computer. And then you have to specify what kind of data you want to open. It can be Excel, it can be CSV, it can be a text and other format as well. So you will specify which one you, and then if you specify, you will open. So we already opened, Dr. Adil, we already did the welcome dialog box, so I will skip this part as well.
Yes,
So
okay.
you have some sample data set in SPSS for your practice. You go to file, you go to welcome dialog box from here, and then you can open any data set from welcome dialog box in the file. So how can you import, let's say, Excel and or XLS data? Because there can be multiple formats to Excel data as well, .xls or .xlsx. So how we do it? So we go to file, we click import data. Here, instead of text data, is you click Excel data, a new window will appear. So here you click import, click file, click import, and click Excel data. So when you click Excel data, oh, wait. Yeah, when you click Excel data, this dialog box will appear on your right side. So here you have to specify which sheet do you want to import, because in Excel you can have multiple sheets, 1, 2, 3, or 4. There can be multiple sheets. So you have to specify which sheet you want to import. Let's say I want to import sheet 1, the first sheet of my Excel file. And then the rest of the setting you can leave as it is. So here you will have preview of what your data looks like. And then you click paste. As I told you, you have syntax that generates a code. You can use that code, let's say later on you have run multiple analysis, you make a code of it, and when you lost your data somehow and you have the original file, you can run this and you will have the things that you wanted. You can just click run and you will have everything again. So just don't confuse it. I will show in practical. But if we click paste, your new data will appear. Syntax basically lets you to save the codes of the operation you did. So paste basically writes the code, the thing which you did in SPSS. Here I imported Excel, so it will write a code that you can, in case in future you want to do it again, you can just use these codes, and it will, without doing anything like from the scratch, you just run, you will end up with this result. This is the benefit of syntax. It just generate your code that you can later use on. So now we will go to SPSS. Again, open your SPSS. Dr. Adil, I want to share the file so that they can practice as well.
Yes, you can send me through WhatsApp. I will send it, them through WhatsApp.
Okay, okay. I'm going to send it so they can practice on it.
Yes. I will forward in the WhatsApp group. You can download. So that now we add Excel file in SPSS.
So it's a bicycle count data before and after improvement of a specific bicycle path.
It's in the group. You can download the file.
Okay, when you download the data, let me know so that I can start importing the data. So you go to file, click it, then you go to import, and then we describe, we are importing Excel data, so that's why we are using Excel. Click Excel. I have already given the path on my computer. You use your path where your data is. And normally I have multiple data. I am using the bicycle count data, which I forwarded to you guys. You can click it and open it. So as I mentioned, we only have one sheet in this data set. If you have multiple sheet, you can click it here, and then you will see that how many sheets you have. If you have 4, if you want to import the fourth one, you will click the sheet 4. And this from A1 to C34, it gives you the range of the sheets in Excel. Let's say we will also open the range of the data from cell A to 34. So it's kind of 34 data points in that. So the rest of the setting you will leave as it is. So you can see a preview of it. You click OK, and your data is imported in Excel. So you see you have 3 variables: observation 1, 2, up till 33. You have data before improvement of bicycle lane, and you see data of bicycle counts after improvement of data. Is everyone able to do this? Did everyone import it? Did it work for everyone?
Yes, it's fine.
Okay. So next we are going to import text data. That's kind of tricky. Excel is pretty simple. You see that you don't have to do any settings, and the importing text data can be a bit tricky because you have to do multiple settings before importing it. How do we do it? Again, we will go to our file. We will go to import. We click open text data. and then here you will see, because we are opening text data, so the file format will automatically be text. And then if we have, so a new window will appear. You see the third one. So if you have a predefined format, you will use that. But currently we do not have any format. We are doing it from scratch. So we will say no, no. So you click no. And then you click next here. So when you click next, another window will appear and it will ask you, because in text data, there is usually a practice. We write data and then we use tab, or we use column, or we can use any other separation in the text data. Because in Excel data or in CSV data, you already have a columns. But when you open a text file, you do not have anything. It's in text. So we use usually a tab, or we use any other thing to make a difference. That, let's say, name, then we press tab, then we say age category, then our next variable start. And this is the type of text data. So here we will define that it's a tab data or a comma data, or which separation you use in the text data. When you open your text data, you will know that which separation have been used in that data. I'm sharing a file, and in that file we have used tab of the keyboard to separate between the data. So you verify. So you here you click delimited, uh, and then you specify where your variable name start. Is it in the first row, or in the second row, or in the third row? So you specify the row where your variable starts, or a line number where your variable start. Normally the data which I'm putting, it start on line number 1. And then normally there are two practices, like decimal. Here in Europe, Dr. Adil knows that they use comma for decimal point, right? And in major part of the world, we use period, like point, to define a decimal. Let's say 13.40. So in major part of the world, they use decimal point, but here in European countries, they use comma. So you have to define also which decimal symbol is used. So if it's a period, so you use point. If it's a comma, like in European countries, if the data is in common, you click comma. So normally the data which I have, I think it's in point. So sorry, it's in comma. So we will click comma, and then the next tab will appear. You click next. So next tab will appear, and here you have to specify where your where your case data begin. So normally the first column are our variables, you see, and the cases starts from line 2. If it starts from line 3 and you have an empty space, you will write 3 here in this column. And rest you can, if you want to import, let's say you have data of 10,000 and you want to import the first 1,000, you can click the first 1,000, or let's say first 50 cases only, if you have a huge data set. And then you click next. Again, you have to mention the delimitation between the variables. So normally it's a tab data. Then you click tab if comma is used or space is used to between the variables. So you click it here, and when you click and finally you give the name to variable. And when you click next, your data will look like this. And when you click finish, your data is imported. So now we will do this exercise in SPSS. So I'm sharing the text data, and Dr. Adil can share it with you, and we will try to import that data ourselves. I share the data, Dr. Adil.
Tufail, just one thing, can you rename this file a bit and then you can send me, just like you name it data.
Okay, rename it. Okay.
Yes, just send it by the name of data.
Here you go. So data.txt.
Yes. Now you all have this text data. Let's learn how to import in SPSS.
So you click file.
Just one second. Let them download, please.
Yeah, okay, okay. So
Everybody
you
downloaded?
go,
Okay.
so you go to file, you go to import data, then you can specify it's a text data. So I will click text from import data, and I can only see, I can see multiple because you see here, there are a lot of types that are open. So normally it's the data, name data.txt. I will click it and press open. And then there are 6 steps as we saw in the slide as well. Normally, we do not have any specific format, so we will click no. Currently, the data is looking like this, so we will try to bring it to SPSS format. So I will say no because we do not have any predefined format. If you have, you can say yes and browse it, and then you don't need to repeat the steps. You will just have this the format, and then it will, you can click finish. But currently we do not have. We will say no, then we will click next. Here, as I told you, this data is in tab form, so we will click delimited. And then where is your variable name starting? If you open the text file, just open it in your computer as well, that you can see. Everyone open the text file itself in a separate window. Then you will know what I am talking about.
So the variable names are at the top.
At the top. So normally it is at the top, but if it's in the second row, you have to say it's in the second row. If it's the third row, you will say it's in the third row. You see, just look at the bottom of the screen here. If I change, you see this number 2, it's normally Alma in your data sheet, and it's coming on the top is a variable name. But we have number 1, you see the difference?
Yes, yes, yes.
Uh,
It's fine.
yeah, and then normally here, because it's data from Europe, so they have used comma as decimal. So I'm clicking comma. Normally in other parts of the world, they use point. So I will say, yeah.
Tufail, a question from.
Last question, could you please repeat that again? The variable names.
Okay, the variable names. Okay. Normally, our variable names in the data sheet, the text data you have, our variable names are at the top. So we have to tell SPSS where our variable name starts. Normally, if you have opened the text data, you see names, workshop, gender. These are our variables, okay? And if they are not in the first row, you have to specify the row.
Oh.
And if you say, let's say our line number 2 is a variable, so it will take line number 2 as your variable names. But you see here, normally it's a case data, not a variable data in this box. So we always have to tell SPSS where our variable names are starting. And here in the text data, you have it on row 1. So we always write row 1. In case if it's in row 2, you say row 2. If it's in any other row, you say define that row. And then you click next and define how you have separated the points. And then you can click next. And here, oh, it's, and now you have to define where your first case, your appear. Normally, it should be the second row. But if it's starting in 10th line number, you can say 10. but you see you're losing a lot of data. And the sheet which we are using,
The first row
that
is variable names. From the second row, our data starts. So that is why we are putting number 2. Yes.
yeah. If you have it in number 3, you can write number 3 just so that you know. That's why I'm telling. And each line represent a case. Every line number in the text data is a case. Yes, that's true. If no, then you can change. But because
This is
we have
one
it,
case, this is
yeah,
second case, this is third case. Yes.
and then I want to import all of my data, I will click all the cases. If you want to import only 5, you can say 5, but I'm importing all of the data. And then you click next. When you click next, my data, you see data is coming into a format now, step by step. I have used tab in the data. You see, if I remove tab, I don't see anything because tab is separating the data. So if I click tab, you see everything. And then, yeah, and then you click next and you give a name to it. For example, you can change, let's say, because these are name of person. I give this name. You can give any name. Okay, original. So you click next. You see this one is changed now because I changed the name here. You can use the name to your variable, this one. You click next, and then you can save it because in the first step I told you if you have predefined format, you have this format now, you can save it. And then you can import and your data will automatically be imported and you don't need to repeat all these steps. But I'm not saving it now. So you say no. And the thing I mentioned you about syntax, you can save the codes. If you want to run it again, you just click. I will show you. So I will say that I want to save that syntax of it, just for you to know. If you don't want to paste, you don't need to paste. I say finish. You see this line of code appears. And if you can save it, I can give it to my colleague. He will have the data. He run it. He will automatically get the result. So I click run, and
I
you will
cannot
have,
see you. Yes, I
yeah.
cannot see you.
I will when you click run. Uh, normally, yeah. So when you click run, you will have your data imported, everything. So this is the data you imported. The practice was only to show you that you can paste the syntax. If you don't want to paste the syntax, you say no, your data will directly be imported. So this is the data which we imported.
It is imported in your case? Okay.
So it's clear now how to import your data, text data. So now there is a small exercise for you. I will send a
Yes.
CSV data, Dr. Adi.
Yes, Mr. Tufail, just one question.
Click CSV.
Yes. Tufail, in one of the students' case, the syntax is showing like the red color. I think these are the errors. I think, Tufail, one thing, because I want to keep things, for example, simple right now for them, because
Yeah,
the syntax thing could be really confusing for them. I think just
yeah.
simple
So
syntax allow them
I will
to.
I will run the I will run the analysis again without syntax. Just follow me.
Yes.
Without
Now you can.
syntax. I just wanted to show like if you want to save codes, that is helpful for later use. We will
Yes.
run it without syntax this time.
Yes.
I'm going to share the screen again to the
Online, now you can
SPSS.
follow us.
Okay, you click open, you click import. I'm repeating it again. The next exercise is for you to import this CSV data. So text, I say data, open. So I'm not using any predefined format. So I will click no. I will click next. Everything as I mentioned before, tab, comma. I'm first row is my variable name and I'm using comma, let's say next. And then my case is started row 2. Each line represent a case. Next. Okay. Yeah, one thing. If you see, because this person has a name Ahmed space Aisha space Aziz, and then we have used tab and then one workshop one, then the gender is female. If I say space, you see it brings Aisha to workshop because we haven't used space between the variables. It's only for the name. We have used tab as a separator. So I will click tab only. Okay. So if you have used space, then you can use space. But here we haven't used space. We have used space only between the names, for example. So I will not click space. So I will say next. I'm giving the same like names. I will click next. I'm not going to paste syntax. I will say no. I will finish and I will have my data imported. Is my data appearing to you?
Not yet.
Okay. It will show up in a second. So here is the data imported.
Yes. Now we can see.
Okay. So we haven't used syntax because, as I told you, syntax is codes that you can use for later. If you don't want to use it, no problem. You can just import it. And then most importantly, you have to save this data because you have it in text data. If you close without saving, you will lose the data that you imported in SPSS. You have to re-import it again. That's why, to be on the safer side, save it in SPSS format. Did everybody follow it? And it worked for everybody?
Yeah.
So now your exercise is to import a CSV data. Because we imported Excel data and text data, and now I will share a file. You have to import a CSV. Try it if it works. If there is any problem, we can resolve it. Dr. Adil, I'm sharing a file with you,
Okay, that's fine.
a CSV file. They can
Okay.
try to import a CSV file.
Okay.
Okay, it's the name book1.csv.
Okay, I got it. It's in the group. They are well aware of the CSV file because we were having hands-on experience on Smart PLS that works with
Okay.
CSV files.
Yeah,
So
CSV, in importing it in SPSS is also pretty straightforward, but try it yourself. You will see it's pretty straightforward.
by the way, Tufail, can you please explain? I see numbers before you improved something in the bicycle infrastructure in Belgium, and after that,
Yeah,
like what is
basically,
51 and what is 57?
this is the bicycle count. There were multiple observation, like 33 different observation at different time period of the day. And there was a bicycling that was going to be improved. And there was, this is basically account data. A
Okay,
bicycle, how many bicycle use it at specific time period. So before improvement, like 51 observation one, let's say it was 10 a.m. in the morning. Normally 51 people were using, but after improvement, making it more safer and more comfortable. At the same time, 57 people were using. Let's say 10 a.m. 57 people were using. So normally we will have we will test this in later exercise as well. That did we see any improvement? Let's say the bicycle path was improved. Were more people using it? This is one of the exercise we will be doing in SPSS as well. That
okay,
like we want to see that like, did improvement bring more bicycle on the roads? Yes or no? So
Okay. Just let me explain one thing to Fel, just one
yeah,
thing. Basically, in his PhD, uh, in Belgium and in Netherlands, they people use bicycles a lot.
yeah,
Like maximum number of bicycle usage in the world is in Netherlands. So
exactly.
basically, Tufail's PhD project is to improve infrastructure of bicycles. What are the problems in the existing system? Are there any like whenever somebody is going by the bicycle, maybe there are some unsafe situations where the infrastructure is not properly designed. So what they did, they put some sensors on the bicycle, and then they were traveling around in the city where they see bumps, where they see some ditches, or like they collected data, some real life data, so to understand the problem in the system, so that then they can suggest it to the government agencies that in the city, these are the places where we have problems. So these problems could be resolved. So many people, even professors, are going to the universities, senior professors by bicycles. It's very common. I saw an image, the Prime Minister of Netherlands was going to his office by his bicycle. So the mayor of the city once he visited our office, and like I was also entering in the building, and I saw he was alone. He was blocking his bicycle in front of our university, and I said, he's the mayor of the city. So this is how their system works. So bicycle has highest importance in that environment. Yes, Mr. Tufail, you can continue.
Yeah, and one more thing, and when you, Adil, have experienced it, when you are on the road, on bicycle or on foot, you have the first priority over the cars. If you're crossing the road and you put your foot on the pedestrian crossing, the car has to stop for you. So this is how they give importance to the pedestrian and cyclist, and that's one of the reason they are prioritized. There is a best of the best infrastructure for bicyclists, and they use it because they are prioritized in their infrastructure for it. And yes, Adil explained you about my PhD, and we want to use people to use bicycle. If you are going for 10 kilometer, use your car or public transport. But if you are going for, let's say, 2 or 3 kilometers, instead of taking out your car, contribute to traffic congestion, environmental problem, just use your bike. It will be faster, it will be environmental friendly, and uh, it has health benefits for you.
It will be
So
healthy also.
yeah, it will be healthy. It has a health impacts because I have seen the numbers. If you bicycle for, let's say, uh, 4 to 5 kilometers a day, then you can save around, uh, if I'm not wrong, 400 to 500 euros a month instead of using your car. Because for car, you have to pay a lot of taxes, road taxes, you have to pay parking fees, and then you also have a time value. For example, if you are in a congested city, you're losing your time. That's also important. And if you're using bicycle, you have a monetary benefit as well, along with health benefits and environmental benefits. So we are going to our next section. That is basically how can we manage our data. Uh, Sometimes when you receive data from any source, there can be problems in it. So we manage our data. So there are multiple techniques that we can use to improve our data, or you can say to bring it to the right shape. So we basically use the transform window. If you at the transform, and from here we can compute variables. We can recode if there is a problem in variable. If there is no problem in the variables, if there is no problem in the data, you don't use it at all. But let's say we have a problem in our data. They are wrongly coded. They are wrongly entered. So we have to bring it to the right shape. And that's where we use our transform menu. And if there is another window, that is another tab, that is data. What we do here, if you want to merge two data files, if you want to sort cases, if you want to split your data in two, and you can do a lot more things to it. So these are the two tabs that we use for our data management. In this workshop, we will be only using transform because data It can take time and also can be a bit confusing. So we don't want to split our data. We don't want to merge data. So we only want to fix the data that has in issues. So firstly, there is a function called compute in the transform uh, called compute variable. And here we can make a new variable using the existing ones. Let's say there are 5% in the household. I'm giving an example. There are 5% in the household living in same house, and the income of one person is 10,000. So I want to compute household the income per person in the house. So what I will do, I will compute variable. So let's say if I want to compare between different countries, what is the income per person? 5 people living in a household, they are earning 10,000. If I want to compute it for one person, so I will just simply divide 10,000 by 5. So I will end up, that can be easily done in SPSS. So how do I do it? When I click compute in transform, and then you will end up with a new window where you have to give the name. Here you see, here you have to name the variable and how you want to compute your variable. This is where you give the name, and this is how you want to compute. This is kind of mathematical expression. So I have added up, let's say 1 2 3 and divided it by 2. I will just simply click OK, and my new variable will appear, where my new variable is computed. Pretty simple. If I want to add a new variable, I can use a mathematical expression. So let's go to SPSS again, and I want to import a data. I will share another data, Dr. Adil. Yeah, so they can follow with me. It's a bikeability.sav. So it's already in the SPSS. You can just simply open it. I will close all my excessive windows of SPSS and will open a new one. You can just simply open this data. It's already in an SPSS format. Is everyone able to import it?
Yes. Yes.
Okay. Okay. And then this is a huge data set of, I think, more than 300 participants. It was a bicycle survey data. So you see a lot of variables, a lot of them. There were some problems in the data. So first, we will try to fix this data. And now, normally, just to tell you about data, the last 4 questions, they are, if I go to variable view, I will show these last 4 questions. So we wanted to, we asked people how important is for them that the bicycle should be safe, bicycle lane should be safe, it should be comfortable, it should be direct to your destination, and also cohesive, that you can move around easily. So these last 4 questions are about that. And usually a bicycle path is called bikeable, that when it is comfortable, safe, and everything. So if you want to take an average of these 4 and see how much score each person give out of 5 to these individual factors, comfort, safety, and all those. So I will add them up and then we'll take an average. How bikeability is important from that. That's what the new variable will tell me. So I will go to transform, follow me, and then I will compute. We compute variable from the existing ones. So I will go at the and this left side. You drag it to the bottom, and you select the last. Sorry, you first give the name. Let's say I give name of bikeable paths. Okay, and then I can click one variable, add them, plus variable 2, add them here, plus variable 3, add it here, and plus my last variable. Because I'm taking average, so I will make sure that my mathematical functions are correct. So if I use bracket, these 4 will add up first, and then I will use divide. You can use all these function. You see it here. So if you click divide, so you will see that it is divided. And then I click 4. You can use your keyboard, or you can use this small calculator. And
You
now
understand
if I,
what he is doing, by the way. So Fab, just 1 second, let
yeah,
me. There were 4 questions in the questionnaire where the questions related to the comfort of the bicycle path, the width of the bicycle path, or something like this were asked. But now we want to add all of these questions, and we want an average of these 4 questions. We are making a new variable in the data, and we are saying if somebody is like ranking a particular like element of the bicycle path. Tufail, can you show the questions first, please?
okay.
Yes, then it will be
So
more
these are the
understandable.
question, and these are the label. That's
No,
the label is
the full question. If you
okay.
can, yes,
You can see
yes.
them now. I
So
will.
the question number, for example, the first one, you can highlight the first one. This is the fourth one.
This is the first one. So now, so we asked them, so far you know that all the critical factor of bicycle design category, and you have indicated the relative importance. I will make it short. So, okay. So which category do you find more comfortable? Please rate them so that we know the relative importance of each category. So first was comfort. The next one was safety. The next one was attractiveness, and the next one was directness and coherence. So these 4 categories.
Okay,
Yeah,
now let me explain one thing.
yeah,
For
yeah.
example, Muhammad is in front of me. I am saying Muhammad, for example, if he's living in Belgium, I am asking comfort of the bicycle path is important for you, but on a scale of 1 to 5, how much important it is for you? He's saying 5. 5 means highest. Then in terms of safety, how much important it is for you? He's saying 4. Okay, then the third one is attractiveness. Maybe he say 2. And then the last one is directness. Maybe he say 5 again. Now he answered me 4 questions. He ranked for 4 components of the bicycle path, and he gave me the numbers. But now rather I want to converge or merge all these 4 questions into one. I want to add another variable in my data, and I want to take average. Average means that number will tell me overall response of Muhammad about bicycle path. So that is why we are adding all the response of all 4 questions. If you see the numeric expression, question number 30 plus question number 32 plus question number 33, like, and we add all 4 questions divided by 4. We are taking average, and now the new answer or the result that we will get after compute will give us the overall picture. Yes.
Okay. So we press OK. You see in your data view that a new variable has appeared in the variable view. If you go to data view, so you will see the average.
Can
This
you
is
drag on the right side? Drag your sheet, please, Tufail,
India.
because it is under your picture. Yes, now. So
So
now you
the variable you see the name, and here you see the data for every respondent, the average of these four variables. So I computed a new variable. What can be the purpose? That's the most important question. So you can later use only this variable, let's say with the gender, because this is computed based on the four variables. So you have one variable computed in four variable, and you can correlate it with any other variable. If I want to correlate it with gender, I can correlate it with age group, with income groups for the later analysis. That's why we usually use compute based on. I also give you an example of household income. If I want to know a household income per person, let's say they are earning 10,000. So I can easily use compute function to compute a new variable for their income. So I hope it has worked for everybody. Did you follow
Yes,
or
yes.
you want to practice?
No, it worked already.
Okay.
You can continue.
Okay, so the next now we will compute, or you can say recode.
Yes, Tufail, just one
Yeah.
second, please.
Yeah.
One student has a problem. Let me see.
Okay, okay.
When
Okay, but how to get the name?
yes.
I want to get the name.
So then we will go to transform, and the way he explained, you will just follow the steps and you will add the new. Yes, in the transform section. Anyhow, this session is being recorded for your future reference. You know, up till now we are just adding the data. We will learn analysis also now. Yes, Tufail, please. You can continue.
Okay. So when you open the data, there were some problems with the data, and we want to fix it. There is another function that we call it recode, that we have coded the data wrongly. We can use recode function to fix the issues in the data. How we can do it? It's a practical example in the data. I will show you when we are doing the hands-on experience. So normally it's again in the transform function, you have two options. One is recode into same variable, and another one is recode in different variables. If I want to keep my variable same as is, so I will use recode into same variable. It will only change the labels, rest everything will be same. If I want to make a new variable out of the existing one, then it will make a new variable using the recode function. So how we can do it? So if I want to do recoding into same variable, you will it will pop up a new window. So here you have to select your variable. So from a list of variable on your left side, you have to select one that you want to recode. And here you see old and new values. So let's say it was the values were given wrongly. So here I will specify my old values and what new values I want to give. So here I specify my old and new values. And here is the example that let's say old value was 63, because in this data sheet I used scale 1 to 5 to give importance to variables. But somehow it was coded wrongly. 63 was showing that it is like moderately important, and somehow the data entered was wrong. So I have to fix it. So now I will bring this 63 to 3, that yeah, 3 was the value that I uses for moderately important. So I will add all these values and click continue. So you will have the same variable just fixed. And now we are going to SPSS to see how it works. We are in the SPSS now. I will show you the data where the problems are. So normally you see I have used for every question, when I go to my data view, I have used values, let's say extremely uncomfortable, somewhat comfortable, neither comfortable, but I use scale 1 to 5. But somehow there is problem in the data, it says 11. And if you see this question, it says that 16 is for not important. But here, so the data should be, your SPSS data should always be consistent. You can use 11 to 15, no problem. But every data should be from 11 to 15 then. It
The
should,
coding,
for this,
yes, as we
yeah, yeah,
used in Smart PLS also, the coding should be consistent. It should be same. One
yeah,
means disagree, highly disagree. For example, one means 4 means highly agree. In all of my research, in all of my analysis, this coding should be consistent so that the
yeah.
software can read it.
Exactly. So as I mentioned, you can use these values, no problem, but it should be consistent throughout your data. It's not that we are using 11 to 15 here, and for the same thing, we are using 61 to 65. So we have to fix this issue for every variable. Until here, I see, yeah, it is okay. I'm using scale 1 to 5. I see this question number 12 slash sub question 1 has a problem I have identified. So I go to transform. I I will do changings. I will not make a new variable. So I will only use this function, recode into same variable, and I have to identify. So here I see the labels. And what was the label? I will go to data view and see what label I used. Just give me a second. Question number, oh wait, I can double click it and it will appear in the data view. Okay, so rate each of them. Okay, so just to make sure that I'm transforming the right variable, recode into same variable. It is this one. Okay, so you see below, and then I will add my variable to numeric, value here, and then I will specify old and new values. So when I click old and new values, and then I have to enter my old value and what is my new value. I'm closing all these windows again so that I know what is the current system that I used. So I'm writing it on my paper so that I know 61 to 65. So you have to go to transform, recode, select your variable, and then click old and new values. And here my 61 represent actually 1. Okay. And then I will add it here. 62 represents 2 in fact. And 63 represent 3. 64 is 4 and 65 should be 5. So I add all these values, you will see the values added here. And there is another system. If you have used ranges, let's say uh, I have a continuous number or I have an absolute number, then I will specify the value. Let's say 1 to 10 is category 1. Income, for example, for income. If you have more than 2000 income, you say that more than 2000 to 4000 represent value 2. So we will use ranges then. But currently we have this system. The categories are wrongly, then we press continue and then we just click OK. And normally, yeah. So if you come to data view now, it is fixed. You see, this is fixed now. Question number 12.
61, 62. You are seeing
Yeah,
the same 1, 2, 3, 4, 5. This is
you are
successful.
still seeing
This
these
is
numbers
also
for the next
present.
one,
The other
but for
ones
the
are
first,
problematic. So the
yeah,
coding should be consistent. 1 to 5 in our case, for example. All of these are wrong. Many times it happens when you get the data from the survey of a government department, a lot of mistakes are there. Um, Also, it happened with me in one of the SPSS file. One of the students, she now graduated from masters. At that time, she was working as a research assistant in UPAD, and she, I think, one of our senior professor taught her SPSS somehow, but she made all the codings wrong. When I get the file, I had to transform it to the, I will say, huge level so that I can reuse it. Right now, question
12.
after this, from question
Yeah.
1 to question 5 and then question 12, we see a consistent coding 1 to 5. Here I see everything is non-consistent. So you need to, this is what we call data mining, like cleaning our data before any analysis. Yes,
So
please.
a hands-on experience for them is they now need to transform question 12 sub question 2. This one, the next one to it. So practice it.
Translate question 12 too in the sheet.
This one. Can you all do this question? If you face any problem, let me know. So you can practice on this one. Question 12 underscore 2. Let me know if there are any issues.
And Tufail, I would request you one thing. After this, can we go to the analysis part?
Yes, this is the last part.
Okay.
And then yeah, there are yeah, we are going to, yeah, we can go, no problem. So there are
Yes.
two more things like visual binning, and that's also used for recording. They can follow. I will share the slide, so maybe they can follow these
Yes,
things
they
on
can
slide.
follow. We need to move to analysis part now.
Okay. Yeah.
Because then actually then we have a small break and then there's another session on boss viewer.
Okay. Okay. So
Yes.
they can take a 5-minute break now. So we will start at 10:40.
No,
And then we will.
it's 10:40 for you. For us, it's
Oh, sorry.
12:40.
So they can take a 5 minutes break, take a coffee or water, and then we
And
will
then
start it after 6 minutes.
you
And then
learned
we
how
will
to
start.
put the data in SPSS, how to add questionnaire data in SPSS. Now the purpose of adding data to SPSS is to analyze the information, to get something out of it, to get some output. Now he will explain us how to analyze the data. We don't need to make, I will say, calculations by ourselves. Software will do it. It will give us relationships between the variables, and then we will have lunch break. Okay. So, Tufail, you can continue. I think you can now
Okay.
continue the analysis part. Yes.
Okay. So mm, now we are doing. I skipped few things that are related to coding. You can. I will share the slide with Dr. Adil. He will share, and then you can follow. And if you still have any problem, you can just contact me by email, or Professor Adil can also help you. So the next thing is we will do some basic analysis first to see the trends in our data. So normally we use basic statistics like mean, median, standard deviation, minimum and maximum in our data. So basically these are some measures. Mean basically represents what is the average of a specific variable. Let's say I have collected data from 100 people. What was the average income of the 100 people? Median represent the central value of your data. Standard deviation is how dispersed your data is. Let's say if the mean is 50,000 per year income of a person, so if there is more standard deviation, it means that people average is higher, although, but there is more dispersion than it. There are people that are earning 1,000 a month, 2,000 a month. So this is the measure of, I mean, the dispersion in the data. So
If
how do
standard,
you?
Tufail, just 1 second. If the standard deviation is high
Yeah,
in the data, it means the more scattered is the data.
the
And
more
the more
scattered the data,
scattered is the
exactly.
data, it is difficult for you, for the software to build statistical or regression.
Analysis, exactly.
Yes.
So when we do analysis, there are some always prerequisite because data should always represent. I will add, why do we need these measures? We cannot survey whole population of Oman. We have to take a specific sample, let's say 2,000 or 3,000, that represent the whole population. And then we have these Maya to see if they represent the whole population of Oman. So we can use descriptive statistics uh, in your analyze. When you go to analyze, click analyze, then you go to descriptive. You have frequencies, you have descriptives, and when you click explore and you add variable into it on, and then you will see the trends in the specific variable. So let's say I want to see the age. When I click age, I can click statistics. I can have descriptive statistics. So it will give me mean, median, standard deviation, minimum and maximum. I can also plot charts. I can also click what kind of plots I need. That's a histogram. So when I click it, I will come up with a summary of the variable that I wanted to explore. And I will also have some charts and graphs. This is one way of exploring. Of course, you can also do frequencies. It will give you frequencies of your variable. It can give you descriptive of your variable. Now I'm going to show you how we can do it in SPSS. You can open up, I will try to open up pre-existing data from welcome dialog that I showed you before. So I'm using demo dataset. Let's assemble dataset, open it, and let's say I want to see the income of the people of this of this dataset. I go to analyze. I can use 2, 3 function. I can use frequencies. I can use descriptive. Let's start with frequencies. In the meanwhile, you can also load your data in your SPSS so that you can follow. Go to frequencies. I want to see household income in thousands. I click here. You can go to statistics.
Your screen is not visible.
Oh, strange. Okay, I will share it again. No problem. Okay, is it visible now?
Yes.
Okay, so I go to analyze. I go to descriptives. So I can use explore. I can use descriptives. I can use frequencies. Let's say we start with frequencies. I want to know the household income is in my variable. I can, what kind of statistics I want? I want median, mode, which and some, let's say these I want. I can have standard deviation, minimum values, maximum values, all these statistical summaries if I want. I can use them all. I also want to build chart, what kind of chart I want. Let's say I want a bar chart. Leave the rest and click OK. I hope the output is still visible.
Not yet.
Output, here is the output. So this is the statistical summary of my income variable. So there were 6,400 cases, and mean or average income was 69,000 point something. The median shows that which income categories were repeated the most, and people were having, like most of the people were having 45,000 income category income. And then we have standard deviation and rest of the statistical variable. Minimum shows you that there was a person who was earning like 900 or something, and there was a person who was on the higher, it's from maximum. And then you will have the bar chart of all those people.
You
So
see these
you can,
kinds of charts often in research articles. They are just producing through the software, just copying it and pasting later on in their paper.
So we will perform another function. This is the descriptive. Now I'm going to perform another function in analyze. We can, as I told you, the explore. What this does is, we put a variable in it. Let's say I want to see another variable, year with current employer. So here you only click descriptive, it will give you all the descriptive. You can also do some other tests. For example, normality. What is normality? Normality is basically showing you that the data is centered around the mean. There is not much of the in simple terms, that the data is symmetrical and the data is centered. You have a mean value and the data is centered around mean. The data is not much dispersed because, as Dr. Adil told you, that we need these assumptions. We want to run our analysis because the data should represent our actual population. Because 6,400 people doesn't mean that is the whole population of Oman or any other country. So we have to take a sample, and that sample should represent the actual population. So let's say I want to do normality test. So I want both statistics and plot. I will click OK, and I will see them in my output view. So you see them in output view. It is doing the same thing with only one click, exploring the data. So you see all these statistics and all these histograms.
Your screen is again, we are not
Okay, I
seeing.
will here. Okay, so these all statistics appeared again, standard deviation, minimum, maximum, along with some other additional things. Histogram was also in the first one. We also see some, other tests. For example, this is called QQ plot. This is the mean of this line shows, you see the data is centered around the mean, that we can say that the data is normally distributed. So this is what Explore does. It shows you the trends in your data. Then you can use these in your reports. You can just click, copy, and paste it in your Word file to show them in your reports. So this is your descriptive statistics. Similarly, we can make graphs. We go to graphs. We can make charts. If I only want a chart, I will do it the simpler way. So if I want a bar chart, I will click bar chart, simple chart I want. Okay, let's say we want a bar chart of income categories. And then I will put them in income and axis, like category axis. I will click OK. I will have the bar chart of my income categories.
So for example,
You can
I can see, it is hourly income, like under $25. We have a count, then mostly people have income between $25 to $49 in our data. Per hour, or I don't know what is the explanation of that. So it's per hour. Okay, it's in thousands. Oh, sorry.
So like 25,000.
Yes.
They are in a month, let's say.
Okay.
So
In a year, I think maybe.
25,000, yeah. It depends on like the data. So it is, let's say it can be 25,000 in a year. So you see that like majority of the people are earning between 25 to $49,000 per year. So these graph and charts and tables are useful when you have the data and you want to write something about your data. Then you need these charts and graphs to tell people or to tell government or to tell, let's say, your supervisor that, yeah, this is the data that I collected and this is what it shows. And based on your research, and you can then see that what this data shows actually. So you can also use bar charts, the clustered one, let's say. If you want to show multiple categories, let's say male and female and then income categories, we can add them, let's say the same. So you go to analyze, you go to, sorry, not analyze, you go to graphs, you go to bar, you can make clustered ones, define, you can cluster, you can have your income categories, and then you can cluster them based on let's say years with current employer. That, and then okay, I have to make it short.
Again, your window is
I
not.
haven't pressed OK yet because I'm wait. So I clustered them. It's running, so you will see this kind of cluster. So this is now showing me years with current employer and how much they are earning. So I can draw some insights into it. So if people who are having more time with the employer, let's say more than 15 years, they are probably earning 75,000. If you stay with one employer for a long time, the data suggests that there is a high chance that you can earn more when you stay longer with one employer. So you can cluster them, like you can mix two categories. So these are a useful way of visually showing the data. Now, you can also use this chart builder, they call it. And here you can do the same thing. And here you have multiple, I will show this chart builder. You can go to graph, chart builder. You have all these type of graphs, simple, clustered. You want to show them in any kind, bar, line, area, depending on the type of data you have, because sometimes you cannot apply everything, every kind of chart to every kind of data. So you can also use chart builder to build charts. So now this is the basic descriptive statistics are making charts and graphs. Now we are going to test some hypothesis. We want to move to analyze our data. So we call it hypothesis testing.
Yes. So, Fail, I just want to add one thing here.
Yeah.
Like, for example, we make an hypothesis. Whenever Cristiano Ronaldo plays for Al Nassr, there are 70% more chances that they will win the game. One statement. So whenever he plays for Al Nassr Football Club, there are 70% chances that they will win the game. Right? It's
Yeah.
an assumption.
It's an
Or
assumption.
whenever Cristiano Ronaldo is not playing for Al Nassr, there are only 25% chances that they will win the game, for example. So these kinds of statements we test through our data. What kind of data we will need, for example, all the matches data that they played with Cristiano Ronaldo and all the matches that they played without Cristiano Ronaldo. Then we can correlate different variables, what is actually happening, or any inference or results that we can draw out of our data.
Exactly. So it's pretty clear. There are some example from the public transport. So you always, when you want to test it, so you have to make null hypothesis and alternative hypothesis. Null hypothesis will be like there is no relationship. Let's say he gives the example of Cristiano Ronaldo. So if Cristiano Ronaldo plays, there is a chance that Al Nassr will win. Our alternative hypothesis will be that if Cristiano Ronaldo plays Al Nassr, there is a chance that Al Nassr will lose. So either when we run our analysis, we either accept that when Cristiano plays, Al Nassr wins, or we reject hypothesis based on the data that if he plays, there's a chance that he will lose. So we need data of the matches. We need the win and loss of the matches Al Nassr played. So there are multiple tests that can be conducted to there are multiple tests that can be conducted to verify our null and alternative hypothesis. It is dependent on the type of data. Let's say uh, like these are the example on the right slide. You see one sample t-test, paired sample t-test, and independent sample t-test. I will tell the uh, difference in them. What is the difference? So let's say I will give again the example of Al Nassr, that Cristiano Ronaldo scored on average of 30 goals every season. And then he played, let's say, 5 seasons with Al Nassr, and he scored a total of 200 goals in 5 years. So then we want to know that is it 40 goals per year or no? Then we use one sample t-test. And if you want to make a comparison between two players, let's say, then you use pair t-test, because you will have two separate data set, two separate players, let's say, and then you want to compare that who is scoring more goals, as an example. Or example from transportation is checking the number of bicyclists on bicycle path before and after improvements. We want to see that we have our data before improvement and data after improvement. We want to see whether the number of bicyclists increased on that bicycle lane or not. We will use pair C sample t-test. And there are always assumptions when you have to apply that specific test. As let's say the sample size, the number of observations should not be less than 30. If they are less than 30, we cannot, because the data is too less. Sorry?
No, you can continue.
Okay. And then if the sample size, let's say we have 30 observation, we will say the data is too less. We cannot run the test, because the results will not be something we can rely upon. We need more data. And then when you have like if you want to compare, then we have independent sample t-test. For example, if you want to compare the average distance traveled per week by female travelers and male travelers, and then we want to know who traveled more, then we will use independent sample t-test. But one thing, if these assumptions are not made, these tests like one sample t-test, paired sample t-test, independent sample t, they are called parametric test. And if these assumptions are made, we use non-parametric test. Non-parametric because they do non-parametric is as simple as that. When there is no assumption made, then you will use non-parametric test. They have a separate procedure of analyzing the data, but software will do that for us. We don't need, but we have to see that these assumptions should be met. Then we have to use this test. Otherwise, we go to the other test, non-parametric test. So how do we use pair one sample t-test? We will use demo data set here. So I want to see that the mean age in my data is 40. Let's say I have 6,400. I cannot manually calculate everything. Let's say 6,400 is a huge sum. If I started doing manually, it will take hours and hours. So I will say that the mean age in the sample, I will specify null hypothesis for me that the mean age is 40 of my population. And I will state alternative hypothesis as well, that the mean age is not 40. It's actually the rejection of null hypothesis. So how do I do it? I go to compare means. I click one sample t-test. And then in one sample t-test, I specify which variable I want to test. And then I will use a hypothesized value. And let's say, as I mentioned, that we are seeing that if the age is 40, and then when I run the analysis, I will have some results. And then I have to see that whether which I thought that the assumption I made about data is correct or not. So we always look at the significance level of the data. And what does the significance level means? Significant level means that do we have enough evidence to accept or reject our hypothesis? The hypothesis was that the mean age is 40. Do we have enough evidence? And in studies, the significance level should be 0.005. It means that I am 95% confident that the result which I have is correct. So when you run the analysis, let's say we can reject or null hypothesis based on significance level. We reject or null hypothesis and conclude the mean sample is significantly different than 40. How can we do that? In SPSS, I'm sharing my screen for SPSS. Okay. Now I will load my demo data set. And I go to analyze. I go to compare means. I click one sample t-test, and then I was looking for age, and then I give a hypothesis. Let's say I give 40. Inside you see 50. Option, leave it. You can also increase how much percentage you want. You can, I mean, then you say that I'm 95% sure. If you increase it to 99, normally we use 95% confidence that I'm 95% confident that the result that I get is correct. So you click OK, and then you will see some outputs as I showed in your slides. Normally, the mean of this data or the average of that data is 42. And I hypothesize that the mean is 50. Based on this significance level, I will reject my hypothesis that the mean is 50, but I don't have enough evidence that it is 50. So what I will say is that we reject our null hypothesis that the age is 40 or 50. And our sample mean is significantly different than 40 years. This is how we test based on this significance level that how sure are we about the results. So this is how you run one sample t-test. Let's say if I want to do analysis for two samples. Example I gave you that we want to see that is there an improvement in before and after. Yeah.
Mr. Tufail, is it possible to, if you have it in your lecture, to show them the correlation?
Yeah, I will
part?
show them the correlation.
Yes, that
This is
correlation
the
will
one
be
test.
fine because the theory behind these tests, I should explain them. Then I will share these slides with them. They will understand better.
Okay. So I
The
will show one
correlation
more
is
test.
something that they will understand quite quickly.
Okay. So before going into correlation, I will show you them one more thing. If you like, this is a practical example that we want to see that like before and after improvements. Like the example which I gave, I'm using the same data as the bicyclist before and after the improvement, and we want to see if there is an increase in the bicyclist. I will run that analysis if you don't mind.
Yes, please.
So let me load the data first.
Your output
And then I will
window
come,
is visible.
yeah, and then I will come to correlation. So I have loaded the data, and then I want to see if we have any improvements. We have 33 observation, and do we see any increased number of bicyclists after improving the bicycle path? So I go to compare means, and then I run paired sample t-test, we are comparing two samples. And in observation one, I put my before, and in variable two, I put after improvement, the counts after improvement. And then I click OK, and then I see results in the output window about my test. And what was the hypothesis that I made was that there is no significant improvement in the number of bicyclists after improvement. But I say that there is our alternative hypothesis, there is significant increase in the number of bicyclists after the improvement. So I will see at my test results, and the significance is 0.01. That means that I'm quite confident about the result, that I can reject my null hypothesis. And null hypothesis was there is no significant difference, but I can reject it. Based on the data, I can say that after the improvement of bicycle lane, there were more people using that specific bicycle lane after improving it. So this is how we use test. Paired test or one sample test or independent test to say something about your data, about your hypothesis. Now the last part I'm coming towards is correlation. Basically, what correlation do is if we want to check if there is any relationship, a statistical relationship between two variables, we can have a very strong correlation, we can have a very weak correlation, and we can have no correlation. Correlation means that if something, let's say, are male using car more or female, is there any correlation of using public transport in men and women? So it's kind of correlation. Is there any correlation between speed and road accidents? Is another example can be, is there any correlation between the comfort of bicycle to the vibration of bicycle path, to the roughness of bicycle path? So then we use correlation. How do we do it? We go to analyze, we go to correlate, we click bivariate, and then we put our variables that we want to test. Let's say I want to test speed of the bicycle and the roughness of bicycle. Roughness is measured by vibration, and in the data set that I'm using, Y represent the vibration of bicycle path. And then you can choose the type of correlation. There are like basically two or three types. Mostly when you have continuous variable, then you use Pearson correlation. And if you don't have continuous, let's say you want to see gender and let's say another category, then you will use Spearman. That is always important. If let's say we are using speed and vibration, both of them are continuous variable, we are using Pearson correlation. Then I will click and then I will have results. So this value shows you the correlation between these value. How do we interpret this value? It is just a number. It's minus 2.08. What does this value means? Then you have tables, or then you can compare it with this one. If this value, this one which I'm pointing right now, let's say if it was 1, then we would say there is a perfect correlation. If it's 0, then it means that there is no correlation between two variables. But I see it's 0.208. It's somehow a weaker correlation. It's not 0, but it's between 0.3. So I will say that maybe the speed is not that much dependent on the vibration of bicycle path. And this is as an example. If you have perfect correlation, if one value increases, that means that the other value is also increasing. In our case, if there was a strong correlation, that means that if I increase the speed of my bicycle path, there is higher chance that my bicycle will bump on the road. But that's not the case here because we have a very weak correlation. So this is about correlation. So now we will apply this test in SPSS. So I'm sharing the data, loading the data I have for this one. Wait, I will open it. Bicycle count. When I load, I will share it. So no, I opened the wrong data set. I'm opening data. It is vibration data. Yeah. Okay. So this was the data that I used. I collected via some sensors. And this Y shows the vibration, I mean the bumping of bicycle, and then this is the speed that was measured by this device. So I want to check if they are correlated. I mean, if I increase the speed of my bicycle, is there any chance that my bicycle will have bumps? I will feel more vibration. So I go to analyze, I go to correlation, I use bivariate where we can use C correlation. I will put my variables speed and let's say vibration. As I told you, we have to always click the right option. We are using continuous variable. It is mentioned from this icon like scale. So we will use Pearson correlation and I will rest. You can leave as it is. You can click OK. When you click OK, your analysis will appear here and you will have this correlation table. And is it in my slide I also showed you here, you can see the value is minus 2.08. This means that there is a very weak correlation between speed and vibration of bicycle. I hope it's clear. I
So
think we are
what if it is 2.08, minus sign is not there?
uh, it is there a minus
Right
point
now,
two.
right now you say there is a
Yeah,
weak correlation between the speed of the bicycle and the vibration that is being faced by the bicyclist
yeah.
because of
So
this value minus 2.08. But
minus
if
2.
the value is 2.08, minus sign
Yeah,
is
yeah.
not.
Okay. Then it means that like if there is no minus, correlation can be either negative or it can be positive or it can be zero. One is perfect correlation. I'm explaining it. So if you have positive one, that means that if one variable increases, the other will increase it with it. If it is in negative, here we have in negative, it means that if one variable changes, the other changes in opposite direction. Like
Okay.
if one increased, the other one decreases. This is what negative correlation shows us. And here we have negative weak correlation. This Pearson correlation value is minus 0.208. So if it is negative, that means that if one increases, the other one will decreases. If there is no minus sign, that means that if one increases, the other one also increases, but the correlation value is low. That means that one is increasing rapidly, the other one is increasing with not that much pace, or you can see the value is not increasing rapidly. So this is
And
what this correlation means.
and one result that practically I can get out of, for example, this analysis, it's just this correlation. For
Yeah,
example, if the speed of my bicycle is increasing
yeah,
and the vibration that is being faced by the bicyclist is also
Yeah,
increasing, if they are
increasing.
positively correlated, it means that the infrastructure quality is not that good because there are a lot of bumps on the road, and as soon as you increase the speed of the bicycle, you feel more vibration. So it
Yeah.
means there is a need to improve the quality of the bicycle path,
Exactly.
pedal path.
This is how we correlate, and based on this, we can draw inference about our data. And based on our result, we suggest something for the government or to make improvements in, let's say, the bicycle paths.
So you
So,
gave a very, yes, yes.
if anyone have any question, they can just shoot their question. We are almost running out of time.
I know you are
Uh,
all very tired now. And
yeah,
yes,
It's zero.
but if the correlation is zero, it means if the value is zero, it means there is no correlation between the two variables. The data says that they are not linked to each other, right?
yeah, they are not linked to each other. They are not dependent on each other.
Not
So,
dependent on each other.
yeah,
It
no
means the
dependence on
value
each
is
other.
zero. The correlation
One
value.
increases, that one won't increase or nothing.
Yes, nothing happens to the other. So anyhow, Mr. Tufail, thank you so much. You gave a very nice introduction to the software, and I also believe that like these are those things that we learned over time, and these softwares you become expert of it when you practice on the software. You cannot learn swimming by just you are outside the water and you are seeing people swimming. You cannot learn swimming. You have to dive into the water and you have to play with
Exactly.
the software. You have to read research articles, and at the end there comes a stage in your life as a researcher when you become expert of it. I believe that Mr. Tufail introduced the software in a quite good way. You all know that there is a software SPSS, how we import data, how we can create some basic charts that we often see in the research articles. So it's up to you now if you want to learn some more advancements. Like there are a lot of online materials available. Also, I can also recommend you one very good channel from where you can learn statistics and SPSS in more details. So, Tufail, thank you so much for your input, for your time. I know, like you had been very busy. He just became father, and congratulations to him.
Thank you so
And
much. Thank you so much.
he
Yeah, I
was
was
very
lucky to.
busy, and I requested that please you need to give a lecture to my students. And a few days ago, 2, 3 days ago, he was in hospital, and he said it would be difficult, but still he managed to spare his time. So thank you so much. Congratulations to yourself
Thank you
for
so much.
you had a daughter now, right?
Yeah, I have
Congratulations.
another daughter, so I have two daughters now. Yeah, lately, like 2 weeks ago, I have a new daughter in my house. So I was busy with her, so but still, I wanted to deliver lecture. And thank you, Dr. Adil, for inviting me to this lecture and sharing my experience and my data that I use. Yeah, as Dr. Adil told you, it takes time to be expert of anything. Like if you ask me like 4 or 5 years ago, I couldn't even make charts in SPSS. But with use, with data, with expert research, with some lectures, with some tutorials, I learned it. Now, if you ask me to analyze the data, I will quickly use my mind which analysis I need, which correlation I need. So I in snap of a finger you can do it after years of research, after years of experience, after years of using. So it's not difficult. You just need to invest your time, and it's a good and practical tool that you can use for your data analysis, and run some models. We were unfortunately couldn't run some models that can be used for predictions, that can be used for decision making kind of stuff. Uh, but still, I would thank you all and for your patience and for listening to me for almost 3 hours. And I would like to thank you, Dr. Adil, and German University for inviting me for this lecture. Thank you all. And if you have any question, Dr. Adil can share my email. You can just send me an email if you are facing any issues in your data. If you want to have any help in the analysis in your master thesis using SPSS, you can just bump your question or shoot your question through emails.
Inshallah. Thank you so much, Mr. Tufail. And he's also expert of urban planning theories. He like the models of urban planning. Basically, as like he introduced, he has bachelor's and master's degree in urban planning. So how the cities are developed and what are the theories behind it. So maybe in one, I'm not sure, but maybe in one of the courses we will invite Mr. Tufail here in the university so that he can share some of his knowledge on urban planning theories. So thank you so much once again. Now we will have break.
Yeah.
So,
Good luck for your next session. See you next time. Bye.
Thank you. Bye-bye. So Dev, thank you so much to you also. Now I will stop recording the session.
Thank you, Dr. Ahmed, and thank you for this opportunity.
And I hope it was helpful for you to understand few basics of the software. Are you here? I think. Yes, she already left, and here I will stop recording.